Assalamualaikum and greetings to my wonderful panels, Encik Khairul Azmin and Dr. Azia binti Kamis. I am Sheikh Nurruddin bin Sheikh Muhammad Akbar from BEKGS1. Would like to present my final year project that is about service and maintenance of a generator set. First, I will explain about introduction. What is generator? Generator is an electrical machine or device that converts mechanical energy to electrical energy. Basically, there are two types of generator in the market today. One is direct current generator or known as DC generator, and the other one is alternating current generator or known as AC generator. There are also two types of AC generator. One is synchronous generator and the other one is asynchronous generator. Next, I will move on to my problem statement of my project. There are several problem statements arise in my final year project. The first one, will skipping or neglecting maintenance schedule will result in machine failure. The second problem statement is difficulty arises in determining the essential steps of maintenance of generator set. Last but not least, does existing fault and flaw within the generator may or can lead to machine failure? Next, I will explain more detail about my project objective. My project objectives are: first, to observe the importance of service and maintenance toward generator healthiness. Second, to determine the essential steps of service and maintenance of generator set. Third is to analyze the problems that will arise when skipping generators maintenance schedule. Next, we will go to my project scope. First, research and analysis the relation of service and maintenance towards the synchronous generator set. The second project scope is to analyze the common parameters of the synchronous generator set, such as generator operating with either no load and with real load. Next, we move on to literature review. I will explain with more details about my literature review. The first literature review is about generator basic working principle. This principle is based on Faraday's law of electromagnetic induction. The coil will rotate in between the poles of the horseshoe magnet, and the rotation will cut the magnetic lines of force that lies between the poles. This process will further induce electromagnetic force in conductor. The magnitude of the electromagnetic force depends on the rate of change of flux. Thus, the induced electromagnetic force will create a current flow. Now, I will discuss about generator set components. The main components of a generator are diesel engine, alternator, radiator, base tank, and also control panel. Diesel engine is the most important component of a generator because it will burn diesel fuel to create a rotary motion to turn the alternator. Then, the alternator will turn the rotary motion from the engine to electricity that is used to power up the load. Next, radiator is also important in water-cooled diesel engine. Also, base tank is crucial in holding the weight of diesel engine and alternator. Last but not least, generator control panel is important in starting or stopping the generator, and also in monitoring the generator performances. Now, I will discuss about generator lifespan. But first, what is generator lifespan? It is an estimated length of time of a generator to still functioning. The life expectancy of a generator depends on first, the brand and quality of the generator. A good brand of a generator will ensure a good quality and build of a generator. Second, the size of the generator's engine. Commonly, the higher the size of a generator engine, the maintaining and servicing frequencies will also increase. Third, environmental conditions. In an extreme temperature, a generator will need more servicing and maintaining than usual. Now, I will further discuss about preventive maintenance events. Preventive maintenance is the regular and routine maintenance of equipment and assets in order to keep them running and prevent any costly unplanned downtime from unexpected equipment failure. There are many types of preventive maintenance, but today I will explain the common types of preventive maintenance. First, inspection, or also known as minor service. An inspection event is a comprehensive inspection of the generator and related components of the power generation system. It normally does not include fluid and filter replacement. Next, full service, or also known as major service. A full service event contains the same inspection item or more than the inspection events. Full services generally include fluid and filter replacement. The third one is load bank testing. Load bank testing will detect potential deficiencies in system which may appear in extended operation. Load bank testing also will ensure full rated output capacity. It will remove potentially damaging deposits, commonly referred to as wet stacking, in the combustion chamber and exhaust system, which may have accumulated under lightly loaded operation. It may be required annually by local code or regulation. Now, I will further explain about generator service and maintenance. As we all know, every generator in this world needs to be serviced according to its mileage so that it can sustain or even improve the generator's performances. There are many types of maintenance and service that we can do on a generator, such as regular oil changes, air and oil filter change. We can also do crankshaft inspection. We can even check for impurities or dirt in oil tank. Also, we can check for battery terminals, and we can also start to refill coolant if coolant start to dry up. The power flow diagram is also used in determining the power efficiency. It can also be used for motor. This is the power flow diagram for a synchronous generator. The mechanical power is transformed from mechanical to electrical. This is also known as power input. There are various losses such as friction, windage, stray and copper losses, and also core losses. From this power flow diagram, we can find many parameters such as power input, power out, power converted, Q out, torque induced, the angle, and many more. Okay, now we will move on to methodology. Okay, this is my project flowchart. I start by doing research regarding the project. Then After doing research about my project, I started to design the circuit by using MATLAB. After designing the circuit, I ran the simulation of the circuit. If I get the simulation output, I will analyze the result. But if no, I will start to design the circuit back by using MATLAB. After analyzing the result, if the result that I get is the desired result, I will proceed to report writing. But if it's not the desired result, I will start designing the circuit back until I get the desired result. So this is the circuit that I simulate using MATLAB Simulink. The frequency is 50 Hz. The V line is 6600 volt. The internal impedance for before maintenance is 0.2 plus 2 millihenry, while after maintenance the internal impedance is 0.07 plus 2 millihenry. This is my circuit simulation represent before maintenance generator. The only difference that I make is on internal impedance. The internal impedance for before maintenance generator is 10 ohm and 2 millihenry. Next, I will show my result of simulation for both before and after maintenance of the generator. Okay, so this is my result generator before maintenance. The upper table is simulation result and the lower table is my calculated result. Okay, first we need to find the formula V phase by dividing V line with Z3. Then we need to find SL by using formula 2 pi FL. Then after we get SL, we can substitute the formula into R plus JSL. We repeat the same step to find load impedance. Then we need to find the current flowing to the load impedance by using the formula Ohm's law. After we know the value of current flowing through the impedance, we can find voltage at internal impedance and at load impedance. Load voltage is the voltage that a power source able to supply at its rated load value, while phase voltage is the voltage measured across a single component in a three-phase source. After we have known all the parameters value, we can find internal generated voltage ER. ER is equal to V phase plus IT times RA plus JSL. Okay, so this is my early result for the generator after maintenance. As I said before, the upper table is the simulation result and the lower table is the calculated result. Okay, what we can compare is the parameter value after maintenance is better than before maintenance. Theoretically, to supply power to load will make input power increase. When input power increase, current will also increase. Output power is equal to input power minus losses. So to maintain power output, and if there is no maintenance, losses will be high. Thus, input power will also increase. Okay, as a conclusion, generator is an electrical machine that really needs servicing. Every generator needs to be maintained and serviced according to their respective mileage. If a generator is kept from servicing, the performances of the generator will drop and slowly will lead to generator failure. When a generator is not functioning, fixing it will cost a high price. Thus, service and maintenance on generator plays an important role on generator healthiness. That's all. Thank you for watching.